Welcome to 21 Days of Code. Today we will solve problem 394, decode string. Given an encoded string, return its decoded string. The encoding is k times encoded string, where the encoded string inside the square brackets is being repeated exactly k times. Note that k is guaranteed to be a positive integer. You may assume that the input string is always valid, no extra white spaces, square brackets, and well formed. Furthermore, you may assume that the original data does not contain any digits and that digits are only for those repeat numbers k. For example, there won't be an input like this. So let's see some examples to understand this better. First input is 3 square bracket a, 2 square bracket bc. So the output should be 3 times a, that is this, and 2 times bc, that is this. So let's look at another input. So 3 times A and 2 times C. So the first example was relatively simple, but the second example, you have square brackets inside a square bracket. So what you can do, you can actually just apply a for loop for the outer square bracket and an inner for loop for the inner square bracket. But if there was a square bracket inside a square bracket inside a square bracket, then you would have to apply for loop 3 times. And if there were more, well, how many for loops are you going to apply? So in order to solve this question, first of all, we will be using recursion. So if you are not familiar with recursion, make sure to check out the link below. And also, you need to have some practice of recursion, so at least do some basic questions of recursion for attempting this question. Then let's jump right into the question. This here is the encoded string. Now I know this looks bigger, but this contains all the general cases that we need to cover. So we will do this question in one go. So this here is the common index. This index represents the current index of the string on which we are on. So this index is equal to 0, that is, we are on the first character of the string. Then this here is the decoded string. Now we will make the decoded string. How? First of all, these here are the square brackets. So for the first square bracket here, this is from here to here. And for this square bracket, this is actually from here to here. And inside that square bracket, there is another square bracket, and inside even that square bracket, there is another square bracket here. And this is another separate square bracket. So how do we solve this question? We will use recursion. So first of all, if you are coding in C++, you should know two things. Number one, recursion, and number second, call by reference. And in Java, you only need to know recursion. Why are we going to use call by reference in C++? Well, you can do this question without that also, but in order to keep this index common, in all the recursive steps we will be using call by reference, that is passing index by reference. So if index changes in one of the functions, then that change is reflected in all of the functions. So we'll see how that works. So first of all, this here is the decoded string. So I have written every character except the square brackets. So I've just written the square brackets and no string within it. That's because we will be replacing this 2 in square brackets with the resultant string we obtain. So let's solve. First of all, this here is the decoded string. So we first of all encounter the A here. Then because the index is 0, so we add A to the decoded string as it is. Then we encounter 2 here. When we encounter a digit, we send it to a method. Here the method will be named as make, because this is the name of the method that we will be using in our code. So we will pass this string and the current index on which we are on to this make method by reference. So you can pass this string and index. Then we are on 2 here. So this will generate another instance where 2 is the number of times the string inside is repeated. So first step will be to extract this number. So how are we going to extract this number? We will keep going on and on inside a while loop till we reach the start of a square bracket. Because for example, if we just take 2 here, so what say we can just take 2 here and subtract the character 0 from this. So we will get the value integer 2 and we will store it as n. But still, what if this was the input here, 13? So we would have to traverse the string till we get to the starting of the square bracket to get the exact number. We will see more afterwards. So when we encounter 2 here, we will generate another instance, that is, we will call the make function. So this 2 here will be the number of times the string inside this square bracket will be repeated. So we will call 2 here and then we will iterate BC here. So when we iterate, the resultant string will result to BC and it will be repeated 2 times. So it will result in BC, BC. So this will be the resultant string and this 2 square brackets will be replaced with this. Yeah. So then we store this result from the make function to our original string, that is we concatenate it and then we move on to the next character. Now here, as the index throughout all of the program, that is if index changes in one of the functions, the change is reflected in all of the functions. So if the index changes from here to here, then in our original function too, the index will be changed and we will on the end of the square bracket and then I++ will move the index to P here. So that's why we will be using call by reference, and if you are not using call by reference, you will be making a global variable index. So this index now points to P. Then we will check if P is a digit. No, we add P as it is to the resultant string. We check Q is a digit. We add Q as it is, then we increment the index again. Then we encounter 4. So we again call the make function. Now this gets interesting here. Now what make does is, then we encounter a digit, so we call the make function. So it will be 4 times this string inside. So what is the string inside? AD, then and square brackets. Okay, so yeah, that's it. So when this AD and 4 times, actually we will also add a number here, that is 13. So this is the result. We have to repeat this AD and 13 square bracket 4 times. Now about this 13 square bracket, we will again use make on this. That's what recursion is. Basically it's a function calling itself. So we'll be going inside and inside the string till we reach this last square bracket inside the square brackets. So this 13 here will again call the make function, and then we will 13. So it will again result in this here n and then 2 in square brackets. The square bracket here will again be calling the make function, so it will again result in this, and here for D. So we will see D and then we will return it to this function and it will repeat it 2 times and add it to it. So, and again after we encountered 13 MD, we will again see a 2 here because 2 is outside. So actually this string was supposed to be like something like this, 13 and 2 square brackets. So this will again generate another make function, and it will have n in it. So that's it, n. So what we can see here is this is just like a tree. So recursion basically generates a tree of functions. So here we see that first we saw BC and we returned the BC 2 times. Then we saw 4 times square brackets, so we called make. Make saw AD 13 times square brackets and 2 times square brackets. So first we called make on 13 times square brackets. Inside those 13 times square brackets, we saw m into 2 times square brackets. We again called make on this, and then finally we got to d here. We returned d here, and it is added 2 times here. So the resultant string here would be equal to mdd, and then we return it to here. So the resultant string here would be 13 times mdd. So I am not going to write all the 13 times here, but here it would be AD and then mdd, so 13 times, and finally 2 times n, so n into n. So here, this here is the resultant string. You can actually remove the spaces here. And 13 here is just 13 times mdd. So as it would be a very long string, I am not writing the entire string here. But this is not the number 13, this is mdd repeated 13 times. So then we return this string here and we will add this 4 times here. So the resultant string here would be, I am talking about here, it would be A D mdd, this would be 13 times, and then nn, then again AD mdd, this would be 13 times again, and nn, and this would be 4 times actually. So this entire string here would be repeated 4 times. So that's how the basic understanding of the question is. So let's go to the code. So let's understand the code now. So this here is the decode string function, and first we will complete this function and then move on to the make function, which will be used in recursion. So we are given an string s, which is an encoded string. We create a variable res, which will store our final result. Then we define a for loop. What the for loop actually does is iterate through the entire encoded string s, and if the current character on which we are on is a digit, then we pass that index to the make function, that is here. We will also pass the string, the encoded string, and then we also pass the index, and then after calculating the result, the make function will return a string that will be our resultant string, and we will add it to res, that is our final result. So if the for loop here detects a digit 3 here, then it will pass this index 0 to the make function. The make function will iterate through inside the square bracket. It will detect a as the final string, repeat it 3 times, so the result will be AAA, and then return it to the decode string function. So the result will be res will be equal to AAA, because we will be concatenating the result of make to res. Similarly, when it detects 2, the make function will return BC to the decode string function, and we will concatenate to res, that will be AAA, and then BC. So that will be our resultant string, and then finally we will return our result. Then let's move on to the make function. First of all, we will be passing the variables I and s call by reference, and we only need to pass I actually to call by reference because we want I to be consistent, to be same across all our methods. So if you don't want to pass I by call by reference, you can make a global variable inside the class here, and if you want to pass by reference, here it is. And we actually don't need to pass string s by reference because string s will be as it is, but to save the memory I have passed it here by reference. And then we will create two variables, res and k. Res will store the final result of this recursion step only, not the result here in the decode string. This here is the final result, but this here is the final result but of this recursion step only. And k here will store the string present inside the square brackets, and res will store n times the string which is k. So k will store the result inside the square brackets, that is k will store a, and the res will store n times k, that is 3 times k, that is res will store a, and then we return res, and res will be returned to here to the decode string function, and then we will concatenate it to the final result. So that's ns. So first of all we have to extract n from the string. So we define a while loop. So this while loop will go on till this string, this character present on the ith index is a digit. So for example, let's take this 13 here. First of all, n was equal to 0, so we write n is equal to 0, and currently our index is pointing to 1, so n will be updated as n equals to n into 10 plus this character on which we are on, that is will be as of I minus 0 and 10. So what this actually does is, first of all, n into 10 will shift the entire number to the left, that is it will move a number. If it was on 1's place, it will move on to the 10's place. If it was on 10's place, it will move on to the 100's place. It is to empty the 1's place, and we will be adding the current number, that is 1, to the 1's place. So as n was initially 0, it will be 0 and s of I minus character 0. Now we know that every character in C and C++ has ASCII values associated with it, and in Java we have Unicodes associated with it. So when we subtract two characters, we will get the difference in their ASCII values or Unicodes respectively. So as these values are continuous, for example, if the ASCII value of character 0 is x, then ASCII value for character 1 will be x plus 1, character 2 will be x plus 2, and so on. So the difference will result in those numbers itself. That is, when we subtract character 0 from character 1, we get 1. When we subtract character 0 from character 2, we get 2, and so on. So this here will store the numbers like this. So n will be equal to 0 into 10, that is 0. So 1 minus 0, so 1 minus 0 is 1. So n will then be updated to 1. Then when we move on to the next index, we encounter 3, a digit again. So we again store this as n into 10, that will be 1 into 10, that is 10, plus 3 minus character 0, that will be equal to 3, that is character 3 minus character 0 will be equal to 3, and then we add it to n. So n will be equal to 10 plus 3, that is 13. And then when we move on to the next index, we encounter the starting of the square bracket, so we terminate the loop, and here we got our resultant number 13. So we now know that we have to repeat the string present inside the square brackets 13 times. So that's how we get our number. So n here will be 13. So in this way we calculate the digit n, that is how many times we have to repeat the string present inside the square brackets. Then we define a for loop, and this for loop is exactly the same, not even similar. This is exactly the same as the for loop here, except the starting conditions differ. Here I started from 0 and it would go on to s dot length, that is the length of the encoded string. Here I will begin from I plus 1. Why? Well, first we encounter the digit and we continued this while loop till we encounter digits. And as we encountered the beginning of a square bracket, we terminated the loop. That is, if s of I, the current character, is not a digit, then this condition would result in false and this loop would be terminated. So we are currently on the start of a square bracket. So we want to encounter our first character or digit now. So what would be its position? So if we were on 3 here and we move on to the starting of the square bracket, then in order to encounter this character here, we would need to increment I by 1. So I will be equal to I plus 1. So that's exactly what we are doing here. I is equal to I plus 1. So we move I one place forward, and then until and unless we encounter the closing of a square bracket, that is, we get the resultant string, that is the result string k, which is to be repeated n times to get result, that is res. So until we get k, we continue the loop. So again, in this, if we encounter a digit, then we call the make function and add it to k. So if we see this example here, when we encountered 4, we called the make function, it iterated through a and d, and it again encountered a digit 13, so it again called the make function here. So the make function resulted in m, that is here, and it again encountered a digit, so we again called the make function here. So we went inside till we encountered the digits. We calculated the resultant string d here, then repeated it 2 times, returned here, so we got mmd. We returned mmd 13 times to this string here, and also returned n here 2 times to this string here. So the k here for this loop would result in this AD, mmd and 13mm. So this here is how the make function works in recursion. So we will be adding the resultant string to the k here, and then finally we add k to result the number of times we've calculated, that is n times here, that is 13 for this. And when we call the make function here, so we repeated this d 2 times. So yeah, n will store the number of times k will be repeated, so we store the k repeated n times to s, and finally we return s. So summing this up finally, first of all, we define a for loop, we iterate through the encoded string, we detect a digit, call the make function. Make function will calculate the resultant string, return it to the decode string, we add it to the final result. Then we keep doing this. We again call make function here. We encounter another digit. We again call the make function here. We keep calling the make function until we get digits and until we are getting square brackets to get the resultant string. So we call make here, we call make here again, we call make here again, get the resultant string dd, then here get the resulting string mdd 13 times, get the resulting string here ad mdd 13 times and 2 times n, and then get the final result as this entire string here repeated 4 times, add it to the resulted final result, and then add qc to the end, and that's it. That's how we get the final result. So I would recommend you to go through this entire code and read all the comments, because I've explained every step in detail here. And we will also be submitting code in Java So make sure to check it out also, because we can't use call by reference in Java, so you would need to create a global variable int I equals to 0, that is our index here, and then use this I here for the entire program. So that's how we'll be using the index I in Java, and hope you understood this question well. And I would recommend you to please go through this code if you did not get the question. And yeah, that's it.